Hello, hello. Good afternoon. Can you hear me okay? Thank you. We're going to get started then. I'm going to talk a little bit about master data management with Data Mesh. Just a brief introduction about me and where I work. I'm Danilo Sato. I'm the head of data and AI for Thoughtworks. I've been here for almost 15 years. My background is technical. I've done different roles across engineering, and I landed in the data world when we were trying to set up our global data community with Thoughtworks about 8 years ago. Thoughtworks, if you haven't heard about us, we are a global consulting company. We help clients from strategy to execution. And we've been growing quite a lot. When I joined, we were just under 1,000 people. But according to our last financial results, we are over 12,000 now. We've been around for 29 years, and we've got offices all around the world. And what we do with data, we say we like to help our clients win with data and AI. And that means a lot of different things. These are some of the clients that we work with, but we help them, like I said, with data strategy, governance, data platform, CD4ML, and of course, data mesh is something that we talk a lot about with our clients. And the other thing we're very keen is to spread thought leadership. So Zhamak was with us when she coined the concept, and she wrote the book about defining what data mesh is. But many other thought workers wrote a lot of books for things that became kind of popular in the industry. Continuous delivery, microservices. You can see a few examples here. We've got some publications that we share, so you can register on our website. We like to talk about technology in general. And being in conferences like this is another way that we like to spread the lessons and our thoughts. All right, with that out of the way, so let's get into the topic. I broke it down into 3 sections today. So I'll talk a little bit about data mesh. This being the data mesh theater is not going to be a long introduction, so I'm assuming you've got at least some familiarity with what it is. I'll talk briefly as well about master data management, and then I'll try to bring the two together and where they work or may not work as well together. And I'll try to use an example to make it more concrete. If you look at Zhamak's keynote yesterday, the definition or the elevator pitch of what data mesh is this decentralized social technical approach for how we govern, how we use, how we manage data and analytical data at scale. So there's this element about scale that is important, but also the social technical aspect, right? Not just how we organize the technology, but also how do we think about the teams and the ownership of that data that we're building into the data mesh. In the book and in the article, she talks about the 4 principles of data mesh. Data ownership around domains, I think, is a key one. And I will explore a little bit more about that because it's relevant for this conversation about MDM. Data as a product is another one that I will talk briefly about. And then we've got the other ones that support, like when we move towards this federated distributed mode, we need self-serve infrastructure that makes it easier for the teams to build and manage their own data products. And of course, we need some kind of governance that operates this federated operating model. And a lot of that computational we try to implement into the platform, so we make the governance concerns something that we can either enforce or we can monitor in the platform itself. As a brief introduction, like why is data mesh important, or how is it different, I guess, maybe than how we thought about data in the past? And one thing that I like to recognize is the way that the world is interacting with data and analytics is changing. And those 2 worlds, we used to think of them as separate, where we capture data in the operational world and we run the day-to-day of our business, and then what we do with it and the analytics that we apply is another world. And then we have this ETL or data integration teams trying to bring the data or get data out of the operational systems to support the analytical space. And what we're seeing is those things are coming closer and closer together, right? With the advent of machine learning, we need to use data, but the machine learning model needs to act in the operational world if you're doing things like recommendation or fraud detection or anomaly detection. So they don't live in an analytical post-factum thing that you can just worry about the data separately. That actually needs to integrate back into the operational world. And those 2 things coming together, they bring other sets of challenges. And one of the key building blocks I think that data mesh helps us to tackle this is the idea of thinking of data as a product, right? Or creating data products, and not just as a technical thing, but also the teams that are behind those data products. And that is the building block of when we talk about data architecture with data mesh. We use that to define that boundary. It acts as a unit of ownership. So every data product will have a team that owns it. It helps us define clearly what the interfaces are. So what's the data that it's consuming? What's the data that it's exposing? It brings the idea of defining strong data quality attributes. So defining SLO, service level indicators that we can measure and tie back to that product. So people that consume can know, like if I care about the freshness of data, or if I care about the accuracy of data, maybe you might have different data products that offer different levels of SLOs. And more than that, and this is where it gets a little bit towards the domain-driven design idea, we will try to define the boundaries of these data products close to the business. So we're trying to drive that alignment between how the business operates and how we build technology, and how do we deploy or how do we use data across the business. The other key thing, and Zhamak showed the same slide yesterday, data mesh came to existence when the traditional approach of trying to solve all of the data and analytical usages with a centralized team started to become a bottleneck, right? So if you work in a central data team, there's obviously lots and lots of requests from everywhere across the business, because the more and more people want to use data or want to bring AI into every part of the organization. And as a central team, I think we've got one of our clients, Omar, here. He says, with a company with thousands of employees, how can we as a central team know all the data and understand the data that everyone needs and be able to serve that? So the approach with data mesh and the reasoning behind going to this decentralized model is to embrace that complexity, right? If we're going to have to operate in that world where we've got multiple teams or data across the business, we want to deploy that knowledge close to the business, but we want to create that mesh to connect them together so we can still share and act on that insight. Zhamak took inspiration, I guess, on the idea of decentralization and thinking about domains as the way to split the ownership boundaries from the book from Eric Evans. And I put this one in here because I know in the data world we talk about data domains, and the word domain itself has multiple meanings to different people. And it's kind of like a meta reference, because one of the key things that Eric Evans talked about when he defined domain-driven design is that the language that we use and the names and the words that we're going to use to describe things, they need to be well defined within a context. Yeah, and obviously he wrote this when we were trying to tackle complexity with software systems. How do we build actual, digital products or web services and things like that? So he was noticing this lack of alignment, right? We start talking some tech language that the business doesn't understand, and that creates a barrier for us to collaborate. If we want tech and business to work together, our systems and the words that we use, they should get closer and closer together. And he defines, I think there's 3 key concepts. The book is massive. You can I had to read this book maybe twice to really understand some of the key concepts. But the 3 things I want to call out: this idea of the domain. And in Eric Evans' terminology, the domain is the problem space or the sphere of knowledge where you're trying to apply technology or data to solve that problem. So that should be something that relates to the business. And then you have this idea of models, right? So everything we do in tech or data, we're trying to simplify or represent what the real domain is about into some language or a model that will help us solve a problem in that domain, right? And then this idea of the model will have relevance within a context, right? So and this creates a lot of confusion. People use the same word in different contexts, meaning different things, and then it creates, what do you mean by this KPI or this customer metric or things like that? So with DDD, we're very strict about trying to define those boundaries and defining that language that we use. So if you think about domain as that sphere of knowledge or the problem space, there's always domains within domains, right? So you can say, okay, I work in the retail industry. That's a domain because it's not, manufacturing, or it's not airline. right? So there's a big domain. But then within retail, maybe we restructure ourselves. We have the supply chain side, right? How do we move our goods around, or how do we make our goods? And then we've got the selling side, how it gets sold. Maybe we've got physical stores, or maybe we've got digital stores. That's another subdomain. And we can keep breaking that down, right? In the selling space, well, there's things that we do about capturing the transactions. We do things about deciding pricing and pricing strategies for the product. We do things about managing the order, fulfilling orders. And then supply chain also breaks down, right? Like we produce things maybe, manufacture them, or we distribute things around, so we keep them in different warehouses. We've got the logistics for how things move from one place to the other. We have sourcing, which is where do we get our ingredients or our raw material to make the things that we sell. And I can keep going down, right? Like I can break down logistics. You've got, transportation might be another area, or customs. If you move things across borders, then customs become an important thing. So the way we break down the domain or the problem space, there's already complexity here, but usually your business will be structured in a way to try to operate how they do, right? If we remove all of the data, forget how the tech or the data organization is structured, the business itself has a way that it operates, that it's kind of our initial draft, I guess, if we're going to look at this. And then when we try to solve things within those domains, that's when we bring the idea of modeling. And I really like this quote that, like every model is actually wrong, but some of them are useful. And this is something that we always try, like in software or data, try to represent, we talk about master models or canonical models. And the reality is, like, depending the problem and what you're trying to do, there will be a model that will be more useful than another one. So DDD brings this into the picture, right? That's the way to tackle complexity, is where we could have potentially different models to represent the same real world concept in our solution space, right? So just as a basic example to see how I can show. So let's imagine this is the world. We've got, shapes and colors and things like that. How could we organize this maybe, or put a little bit of structure? Well, I could use a model that separates by shapes. So you've got like triangles and squares and circles, and that's correct. It's a right model if what I'm trying to do is understand shapes. But similarly, that same world I could represent and split things by color and say you've got yellow things and blue things and purple things, and that's also right. So those two things can coexist and represent the same concept in the real world. Depending what I'm trying to solve with it, one might be more useful than the other one. And this is, I think, the key unlock. So if anything we take away from this section of the talk on DDD, DDD gives us the freedom, or it gives us the ability to embrace multiple models, right? And this is something that I've seen not being the mindset when we talk about master data management usually, because there's always an approach to try to create the master model, create the single source of truth, like bring everything together in one place. Let's all agree in what the definition should be for things. And that centralization, it will bring the same kind of bottleneck problems that data mesh is trying to solve at the organizational side. So that brings me to the second topic around master data management. So if we go back to the definition, DAMA, I think, is a good reference. Everyone here should be familiar with the body of knowledge around, like data governance, data management. But the idea of master data being some data that's common or abstract some key concepts for a business. And these are some examples that's probably relevant for many of you. You've got employees in your company, products if you sell things, or your customer will be another one, your vendor. So you've got these things that you need to master, because it's going to be useful for many parts of the value chain. And the idea of master data management, at least the goals of it, is we're gonna manage that so that we have more accurate data, that we can have values that are current or fresh, and we want to try to bring some kind of consistency, right? So we reduce the risk. So if these things, people have different views of those things, then they might come up with different answers. And Gartner talks about different styles for how you implement master data management. So they talk about, consolidation, registry, centralization, or coexistence. And what I've noticed is many of implementations and many of the vendors that sold solutions in this space, they drive towards a centralized or the consolidation approach. So consolidation is more, like for the BI analytics world, maybe. I'm not going to fix the data at source, but as I ingest data into my analytical world, I'm going to put master data management processes and data stewardship and data quality, so it's pristine in the data warehouse or in the analytical systems. So that becomes the master data that we build to do insights. Or the centralized approach, which is more top-down, like bigger surface area. Actually, let's try to coordinate everyone. Like if different systems have different definitions of customers, we're going to create a single source of customer data. There's going to be a new system. We're going to migrate all the data, and then everyone has to use that data from the new source. And this is where it starts conflicting a little bit with the data mesh approach, right? Because both of these approaches assume that you're trying to bring things together and come up with a single representation. The other two, while they're not as much popular in the wild, and I know that because I talk to Gartner analysts, I try to understand as like, who is doing these other ones, right? Because I see a lot of people talking about the centralized and the consolidation, who is doing registry or coexistence. And he told me like, oh yeah, many people don't do this, like many MDM projects, they're trying to go towards the other way. And I think data mesh would prefer more of those styles. So registries where, we're not changing much of the data, but we have a place that we register where those concepts exist, and they might be conflicting, but you can see where they are. And the idea of coexistence, I guess, which is you have different representations in different systems, and then maybe you map out this view of the product here means this thing versus this view means that other thing. And then I think data mesh prefers those, but also puts a little bit more governance around that. And obviously, centralized, some things might make sense. And what I tend to tell people is like, if you're trying to centralize a concept, go back to the domain or go back to the business. Do you have a business owner or a business area that will say, we own this thing, whatever thing you're trying to master? And I have this conversation with clients as well, like about customer, for instance. And it's like, do you have like a chief customer officer, or do you have like a business unit that's trying to bring that single customer view into place? Or are we trying to force that as a data team, trying to connect the things, but no one in the business actually cares about understanding the customer as a thing, right? In those two scenarios, my data mesh view of a customer data product will be different, because if you've got that strong ownership with the business, they will be the ones that will own, and maybe centralizing might make sense. If you don't have that, then coexistence might be more relevant, because you don't have clear owners of those things in the business. And the reality with master data management projects is, despite those goals, the quality is still a problem. And I have a few kind of common reasons that I've seen for failing. The first one is we try to solve it by buying some solution, right? Like let's buy a piece of software. And you can imagine, just the software alone is not going to solve it if you're trying to get people to agree on what a concept should look like or what a data model should be that everyone's going to use. So it needs to go beyond just the technology. And that's where it can get stuck, right? Like getting people to agree or people disagreeing. So it takes a lot of effort. The other one is by going down that consolidation route, we are fixing data quality, but downstream, right? The source data remains bad. And if people can still go around and source data from wherever they want, because we're empowering analysts and empowering data scientists to get data from wherever they need, then they will have to solve the data quality problem again. So as long as we're not solving data quality as close to the source as possible, we're propagating bad data, even if we say in this system the data is pristine, or like we claim some level of quality here, but if everyone is not using, you didn't fix it upstream, then you have that risk. The other one I kind of hinted before, but the idea of trying to come up with these canonical enterprise models that represent something across the whole company, one model to rule them all kind of thing. For any sizable, complex organization, this can lead to a lot of time to get people to agree on what the design should be and things like that. So it's another source of trouble. And then the other one, if we're going down that centralization implementation, tends to be like a big bang, right? Because we're going to have to bring all the data in one place, and then everyone's going to have to consume this data from this new source. So there's a lot of coordination. It's a big change. And we know like big projects tends to have bigger failures. All right, so that brings me to the last section then. How can we rethink about these things, bring together data mesh principles, but solving the master data management concerns? And I'll talk through this using an example from a client that it's probably familiar to many people. It's a retailer, fashion retailer, so they make clothing. And obviously product is a common entity that I think everyone will have in their organization. Whatever you sell, the thing that you do, you have a master data candidate there. The product has a long life cycle, right? So all the way from they coming up with the idea for the piece of clothing to making it, sourcing it, distributing, selling, and all of those things. So it's a good, I think, you might be able to draw parallels to your own world. And if we think about the language, right? Like, so I broke down some of the domains that exist in the client. So design is when they are coming up with the concept. So they might talk about, you know, they use the word products, they use the word style, they talk about concept. When they move towards sourcing, which is like, okay, we decided we're going to make this. In this case, the client doesn't make their own. They buy. They make the design, but the manufacturing is done by another supplier. So they have to communicate to the supplier how to make the T-shirts or the jackets. So they'll talk about bill of materials, or the idea of a SKU might appear. You know, like we need some kind of identifier to start tracking things. And then it gets into logistics, which is moving things around. So when it's made in I don't know, Bangladesh, they need to ship the container with the piece of clothing to where they sell in store or where they have warehouses, and they operate across the world. So you talk about packages or shipments, you know, different words start appearing. Distribution is when it's in the warehouse and we're trying to move things around. They'll have SKUs, but they might talk about pallets or picking things from stock locations across the warehouse. And then they sell it as well. So they might have the product variations, maybe different colors or sizes of the same T-shirt. So you can see here already there's overlaps of similar terms being used in different contexts, but there's also complementary things that are more relevant in a specific domain. If we break down a little bit more into like what might be data attributes for these products that are relevant, here I try to highlight the things that are different between the domains. So in the design world, we care about the color palettes, the fabrics, flavors, you know, if what we make is like a recipe or something like that. In the sourcing domain, I care about the cost maybe. How much is the supplier going to charge me to make this for me? I need to define the sizes now because they're going to make small, medium, large T-shirts. In logistics, the packaging material or whether there's hazardous products. If you're moving across border, you have to declare that. Custom codes, dimensions, distribution, you care about inventory or where it's located across the warehouse. And then when you're selling it, you need the price. You might have to apply promotion or you have photos about the product, right? So lots of different attributes that you could claim to say like, yeah, this is related to product. And if you're going down like a centralized MDM approach, we would try to build some kind of like master product or a main product entity that aggregates all these disparate views to become like the source of truth, the single source of truth for products. And why is that hard? A few things. One, I think for any complex system, like I said, it will be really hard to represent in a single model that answers everyone's questions. Because number two, it will force you to keep data at the most granular level, right? So if I don't know what kind of questions I might ask of it, I'm going to be forced to keep at the highest fidelity possible because who knows? I can always aggregate later. You're forcing a single representation or shape of the data as well. And we all know, you know, there's tons of database vendors here in the conference. There's different ways now that we can represent data, right? Like it's not just a relational view of the world anymore. You might have a graph, maybe model makes more sense if what you're trying to solve is a problem that needs traversing. So we don't want to try to force that. So you're trying to come up with a single model, it will force you to find a similar shape. and it ends up creating data quality issues. And the example I have here from that client, we made, for instance, an attribute that was mandatory in the distribution domain because we need to know, if this, how much space is this gonna take. But when we're designing the products in the first place, I don't even know if I'm going to produce that. So you're adding a required field to someone that the designers have no idea what that field means or how it's going to be used. So what do? They'll put no, they'll put empty, they'll put spaces, they'll put zero. So you start creating data quality issues by trying to force this big model that maybe is not relevant for that domain, and they come up with extra stuff and they'll just fill out whatever they need. All right, so that takes me to the last bit. How can data mesh help tackle this? And I think the key here is embracing that decentralization, trying to come up with these complementary views of the product or whatever concept you're trying to master, and being able to connect them over collecting it. So don't try to bring them all in one place and come up with one model, but if things are related, you can always connect them, and similarly, you can traverse back and infer some insights afterwards if you have to. And to do that, you need a few things. You need this idea of like globally addressable identifiers, right? So kind of like a federation ID for things so that you can always link to them. And if you namespace that to embrace the idea of like different contexts or different domains or subdomains, then you can say like, we're using this ID for this concept in this domain. And we want to be able to link that. And two types of linking that Jean-Marc talks about. One is like the actual physical linking on the data when it's manifesting itself. So I could say photos in the selling domain for this product has an ID here, but it's reference to this style that was the product during the design phase. So I could traverse back. But also in the semantic kind of definition, right? So if we're able to say semantically, the style in a sellable product is the design style that was existing in the other domain, then you can infer, like using that as metadata, you can kind of start building the, I don't know, knowledge graph or ontology or some kind of representation of how the data connects across the different data products. And this is a little bit more, is not a top-down approach because we're not trying to centralize and model the whole world all at once, but you start doing that more bottoms up. And obviously, as you evolve this, there will be challenges or conflicts that you have to resolve, but the idea is we're moving towards this federated model where you have data products that represent slices of that concept, but they are linked together, that if you need to do some kind of analytical aggregation, you can always, where the source is. And in a sense, we are kind of federating the master idea, right? Like each one of these views of the product, they are a master product in that context. But these are different models that coexist and they link together to each other. So to finalize, this is my last slide. Some of the mindset shifts that we would like to see. So shifting from thinking of, chasing that single source of truth, but embracing that actually, why don't we have slices of truth that appropriate domains or appropriate teams can own, right? So it's not trying to bring all in one place. Instead of trying to have a canonical model, let's embrace that complexity, have multiple canonical models, but they are within a context, they have integrity. So you always know what they're trying to solve. Not having a technology-driven solution, but really trying to align with the business, like the example I gave with the customer. And DDD, if you read the book, it actually goes down all the way to the code as well. So the language that we use to define the data products, we would use that in the code that we're writing as well. So it makes it easier for the data engineers or the developers to relate back the same idea all the way back to the code. We're bringing data, instead of being an afterthought of modeling, we're doing that design and modeling up front and taking that as the integral way of designing things. And we're moving from this lack of data ownership to having clear ownership, but still having the teams to be able to operate autonomously because we know kind of which context each one of us operates. So that's what I had to share today. I think I'm out of time in terms of questions, but we have a booth, Thoughtworks, just behind here, the Data Mesh Theater. I'm going to be around for the rest of the day, so if anyone wants to come to say hi or ask any questions, you can find me over there. Thank you.